percent change of dimensions. Percent change of dimensions. Maybe it should say percent change with dimension. That's what you'll have after this. Write this down. One square is 50% larger than another square. One square is 50% larger than another square. And we are going to answer these, that's a little factor. We're going to answer these 2 or 3 questions, 2 maybe. A, the perimeter of the larger square is what percent of the perimeter of the smaller square? A. Perimeter of larger is what percent the perimeter of the smaller. Who's getting excited about this now? Somehow I need to answer that one. Letter B, the area of larger is what percent the area of the smaller. It's more and more exciting. And then letter C is, oh, let's not have letter C, let's just do this. Anybody want to answer those 2 questions right now? I've got time.
I know A.
What's A?
50%.
Now, notice it didn't say what percent bigger it is, it said what percent the perimeter of the smaller. And here is what, kids, this confuses me, and I'm really old and I've done this for a long time, okay? Here's what I always do, look up here and listen to me. When this whole percent thing, because there's a difference between saying what percent something is of something and what percent bigger something is, which is what you said, Cameron. You answered what percent bigger or larger it is. You didn't answer is what percent of the smaller. Here's what I do. I always, in order to get my little ratio, fraction, percent / straight, I change this in my mind to think, instead of saying what percent, I say what fraction. The perimeter of the larger is what fraction of the perimeter of the smaller. In other words, you are going to do this. You're looking for the fraction that has the larger, the perimeter of the larger over the perimeter of the smaller. That's the percent that you want, because that's what it asks you. It doesn't ask you how much bigger it is, it says what percent of it is. So now, the question before we answer this, and that's the same thing here, this would be the area of the larger over the area of the smaller. I told you, most of you will walk away from here just a little not any smarter than you were when you got here, because this won't make any sense. But that doesn't mean we don't try. It takes a few times to sink in. Now, here is the question. Noah clausing. I am going to make an example here, and how big is the small square? I've got time again. But I need numbers. Don't tell me halves or wholes or quarters. How big is it? I am going to draw a square. How big should I make it? What does the problem say? What size square am I starting with? What does the problem say, Maggie Dervis? It doesn't say, which should make you happy, because when it doesn't say, guess what? You get to pick your own, because it isn't going to matter what sizes you start with. The answer to this won't matter whether you use a square that's the size of 50 by 50 or a billion by a billion. So you want to pick a size square that's easy to work with. And what number is probably, well, no, let's just, what number would you start with? Well, the problem with 1 is that you might end up having fractions of parts of 1. I might start with 10, just because 10 generally is one of the easier numbers to work with, right? So there's my small square. Where did I get 10? I just picked 10 because 10 is an easy number in my mind to work with. Now, I need a square that is 50% larger than that. Ooh, so you know it's bigger. If I draw a square that is 50% larger than that, how big would each side be? If it's 50% larger, what's 50% of it? It's that much bigger than that. Here's where a little thinking comes involved. Logan says 50? Yeah. 50, if I put 50 there, that is 10 times 5, that's 500%. It's probably 400% bigger actually. What is 50% of 10? 5. So 50% larger would be, Cameron, 15. 15 is how big my new square is. It is 50%, 50% of 10 larger. Okay. Now once you have that, then the work is pretty much done for the first one. What is the perimeter of the larger square? I can figure that out because I just add the sides. What is 15 plus 15 plus 15 plus 15? 16. Put it there. What is the perimeter of the smaller square? 10 plus 10 plus 10 plus 10? I then just need to make that a percent because that's my fraction, but it asks me for a percent form. Which most people are saying, what is that as a percent? 60 over 40 is what percent? Maybe we should reduce it, maybe we should make it baggy. Why is it 150?
Because it adds up, you're taking the square and the small square fits into.
What? Oh, here, let's reduce this down. Let's reduce it down to what? 3/2. Or 1.5. What is 1.5 as a percent? 150. And that is the answer to where Cameron said it was 50% bigger. It is 50% bigger, but that's not the question it asked you. It is, the original square is 100% of itself, plus the 50%, that's where 150 comes from. Now, what about the area? What about the area? What's the area of the big one? 15 times 15, bonus points for anybody that knows that. 15 squared is, yes, 225. Somebody said it out there, who did? Is that you, Schwartz? What's the area of the smaller one? 100. Now, this is going to be scary. 225 over 100 is what percent? I know that's a tough one. Please tell me that all of you are going to raise your hand because it doesn't get any easier. Since percent means out of 100, and the fraction is 225 over 100, what percent is 225 over 100? Wellman? Let me go over that again. Since percent means out of 100, and the fraction is 225 over 100, what percent is 225 over 100? Yep. You say 225? Yes, 225, very good. This is what percent means. You put number over 100, that's what the percent is. 225 over 100 is 225%. And that would be, children, the answer to both of those. And I can't change that, nor can I really make it any easier. Okay, so let's do another example. I wish I used other colors rather than blue and red because it gets kind of dull with blue and red, but for more than you need. They need to let you be able to put your own colors in that spot there. Here we go. Write this problem down. The towel shrunk. Now when something shrunks, what happens? By 10% when it was washed. So bam. The area of the towel was reduced. The area of the towel was reduced by what percent? Anybody got an answer for me? Don't say 10%. Cameron?
19%.
Stop looking at the book. All right, Cameron, come on up here and do this problem. Let's see if we can figure out how we get 19% by Cameron. Although that's, as Mrs. Stone says, way to use your resources. Okay. So what am I starting with? I'm starting off with the towel. What is the dimensions of the towel? Caitlin Stritzel, how big is my towel to start off with? Give me a, how wide, how high, how deep? Oh, where'd that come from? Exactly, because it doesn't say, but you can use 10 by 10 because you get to pick. And pick we shall. Okay. So, 10 by 10 is what Caitlin says we're going to use for our towel. If this towel shrunk by 10%, what are its new dimensions? It was reduced by 10%. Mrs. Stone!
What?
I thought you came to ask something here.
I did. I'll wait till
It's
I'm
a
exhausted.
long time. Is it of me or of them? Oh, speaking of that, I forgot kids to, if you do this, call Mrs. Stone is here, so. Track, and who's interested in track? I kind of got them, but track says no, so it's probably makes sense, I'm sure of it. Tomorrow, and it's not Friday, that should be changed to Saturday just because of whatever track people. I predict state championships. Believe it or not. Have you been on track before? I'm not forcing anybody to do anything. Oh, I didn't know. All right, anybody else? Okay, back to the question at hand, kids. So if something shrunk by 10%, that means what is 10% of it, and it makes it that much smaller. So what's 10% of 10? Andrew?
1.
And if it shrinks by 1, then the new dimensions are? It's a 9 by 9. Okay. So now we can figure out the areas of both of them. What is the area of this one? 100, correct? The new area is 9 times 9, which is 81. Okay. You know how much it shrunk. How much did it shrink? Well, no, it went from 100 to 81, so how much did it go down? 19. But how does you get 19 to be the same as 19% shrinkage? Because that's what the answer is, but that I didn't get. This isn't a percent when I do it. When actually it is, but. Miss Shaw, Mrs. Stone's been here. You might as well jump in the fray. Oh, was this? Are you guys discussing the same point? Okay. Huh? Oh. It's just not very often that teachers visit seventh grade classrooms. It's just not very often that the teachers come to visit the seventh graders. Now, why didn't somebody say, hey, why don't we draw some sort of a box? Or a fraction table, if you will. Take a look at this. Take a look at this. This is a reduce in percent thing, right? Where we take our original, right? We subtract some sort of percent and we get our final, right? What was our original percent? We always start with 100. How much is our percent decrease? We don't know. Nor do we know what our final percentage is. Those are two we don't know, we're not given. But we do know all of this stuff over here. What was the original area? By how much did the area go down? What's the final area? Which one of these two? Where I asked, did it ask me what percent it was decreased, or did it ask me what the final percent was? Percent decrease, right? Which is this one. Now, how do I go from 100 to 100? So how do I go from 19 to this? So, and that's where 19. Because, children, because we used a 10 by 10 square, and it ended up being 100 to begin with, our percentages are the same as actually the area because you decided to use that. Had we used, 12 by 12, we'd have had to do a little more calculation. That's why when you pick squares and stuff, 10 is a good number because 100 is a good percent to deal with. Nobody cares. No, you don't care. Oh wait, I was gonna ask you a question, but now Cameron was gonna actually look at his book to give you the answer.
No, I won't choose that.
Okay, here we go. This is what I'm gonna let you do because it's I am going to let you look at page 482.